Hi guys! Today we'll be solving a new problem. This problem says, for a recent period of 100 years, there were 111 major earthquakes in a particular region. Assuming that the Poisson distribution is a suitable model, find the mean number of major earthquakes per year. So this one tells us exactly which distribution we're going to be using, which is the Poisson. So we have to make sure that we use the Poisson tab in our Excel document. And we need to find what the mean number of major earthquakes is per year. It tells us that there's 11 major earthquakes in 100 years, so we need to change this value of 5 to be 111. And here we need to change this time into the number we're looking at per year. So we have 100 years and we know it's 111 for 100 years. So if we change this value into 1 year, so 1 divided by 100, basically representing 1 out of 100 years, where you're going to get the decimal value of 0.01, and then it gives us the mean value when we multiply these two things of 1.11, but it tells us to round to 1 decimal place, so we should just end up with 1.1. And that is the correct answer. Now the next step of this problem is to find the probability distribution for the number of earthquakes in a randomly selected year. So first we say 0, and we're trying to find the probability that it happens 0 times, which based off of our chart is 0.3296, which is what we were looking for here. Then we look in C1 and we see 0.3658. That matches here, and we keep going and we keep going, and as you see, they all continue to match, rounding to 4 decimal places. So this chart is really helpful in solving this problem. It goes all the way to 6 plus, which we can just leave as 6 here as 0.0009, which is, they rounded it to 3 decimal places here, which they should have left it at 4. But the idea of when you round 0.0009 to 3 decimal places, it becomes 0.001.